Am I audible? Just write yes on the chat if I'm audible. Just write chat yes on the chat if I'm audible. Yes, yes, I can hear myself. That means I'm audible. So, uh, hi guys, I'm Prateek Garg, basically your master teacher in physics. So, here in this today's session, I will be discussing some of the very good shortcuts that you can use in JEE Advanced as well as different exams that you might be writing, like the exams which are still not over, or you know, uh, different engineering exams, whatever entrance test you are going to write. So these techniques will help you in advanced as well as different state level or different kind of engineering exams as well. So stay focused, guys. And there are two parts because all the techniques I could not cover in part one. So there are two parts. The next part of this will be released tomorrow. So I'm sure you're going to love it. The only requirement is that if you have done your basics properly, then you will definitely love these advanced techniques, right? So without me wasting much time, let us start. The first is tension formula. Now, what is this tension formula? I'm sure that all of you would have studied uh, the questions based on pulley. You would have definitely seen this question. This question is also in HC Verma book. So let me tell you one more thing. Today's session will be helpful for those students who are going to write JEE Advanced in 1 month, and also for those students who have completed their class 11th. So that means even if you are right now entering in class 12th, then also this session is quite helpful to you, right? So what I'm saying is, okay, now let's come back to this question. So suppose we have to find the acceleration of any block. I'm sure all of you can do this question right now. This is a very, very easy question. All of you know how to solve this question. It's not a big deal. But suppose if I can tell you a magical method wherein you can write the tension, like let's say in 10 seconds. Suppose I say that the tension, let us say in this string is T. So if I can tell you a magical method using which you can write the tension, let's say in 10 seconds, then wouldn't it be great? So, so we are going to discuss that method itself. So what I have done, I have taken 5 to 6 similar kind of questions, wherein please listen to me very, very carefully, because the first time when a student hears this kind of a formula, so he is like, kind of disturbed for some time, because he feels that, how is this possible? But this is very much possible. That is why this is shortcut. Now, uh, so please listen to me very, very carefully. And I will tell you the explanation and everything. I will tell you the proof. I will tell you everything regarding this formula. But just listen to me very, very carefully. Initially, for 1 minute, you will feel slightly, uncomfortable. You will feel slightly disturbed, like, how is this possible? But so let's see the formula. So suppose the tension is T over here. Okay. So in this string also, the tension will be T. So here the tension will be 2T. This is very, very obvious for all of you, right? Now, how to write the value of the tension? Look at this very, very carefully. So this block is going to accelerate on y-axis. So what is the component of gravity on y-axis? G. And multiply this G by the coefficient of tension. So what is the coefficient of tension? 1. So give me 2 3 questions, then you will be able to understand. So here the coefficient of tension is 1. Here also the coefficient of tension is 1. Here the coefficient of tension is 2. What do I mean by coefficient? The number just beside the tension. That means here it is 2, here it is 1, and here also it is 1. So what I am saying, this block is going to accelerate on y-axis. So multiply gravity by 1. What about M2? This is also going to accelerate along y-axis. So multiply gravity by 1. This is also going to accelerate along y-axis. So multiply gravity by 2. By 2, because why have I multiplied this time by 2? Because the coefficient of tension is 2 over here. Divide by 1 square by M3. Okay. Here see it was 1. So 1 square by M2. Okay. And here I have written 2, so 2 square by m1. So this will be the value of the tension. I know you would be very uncomfortable, like you would not have understood what have I done. Give me 5 questions, you will understand everything. Okay. So this is what have I done. Let me take another situation. Again, this question all of you can do. Let's see how to do this by tension formula. So if the tension is T here, so tension will also be T here, because you can see this is the same string. You can see that this is the same string, but the tension value will be 2T here, and it will also be 2T here. Now, how to write the value of T? Very simple. So here the number is 1, here 2, then on M3 it is 2, and then on tension on M4 also it is 1. So 1 into gravity, then 2 into gravity, then again 2 into gravity, then again 1 into gravity. Divide by 1 square by M1 plus 2 square by M2 plus 2 square by M3 plus 1 square by M4. This will be the value of the tension. The moment you write tension, I am sure the question is over, because now you can write the acceleration of any blocks. Let's see the next question. I will come to the explanation part very shortly. Please do not be uncomfortable. I will come to the explanation part. Just I am telling you what part right now. That means what you have to do. Why we are doing this, I'll come to that later on. This is an Atwood machine. All of you know the answer for this. I have taken this question just to tell you, just to prove that whatever we are doing will give you the correct answer. So if you have remembered, if you have memorized the value of the tension, then it comes out to be 2m1 m2 divided by m1 plus m2 into gravity. So your teacher might have told you to remember this result, because this is the value of the tension in the Atwood machine, right? Now, how can we write this result by tension formula? So again, the if you suppose tension is T here, so there will be tension T here as well. So our formula tells, so what is written beside tension? 1. So 1 into gravity plus 1 into gravity, divide by 1 square by m1 plus 1 square by m2. So you can see this becomes 2g divided by 1 by m1 plus 1 by m2. So this becomes 2m1 m2g divided by m1 plus m2. So if you have memorized this result, you see that it matches with the result that you would have memorized. Okay, let me go to the next question. So this is an infinite pulley system. Infinite pulley system, m1, m2, m3, m4. You can see the system goes on till infinity. So how can we write the tension? This is a very nice question. This type of question you might see in advanced, like this is an advanced level question. So again, if I write tension T over here, so what will be tension over here? T by 2. So what will be tension over here? T by 4, right? Because the tension will get distributed equally in both these parts. So what will be tension over here? T by 8, right? So this series will go on. So how to find the value of tension? Again, so what is the value of tension coefficient here? So it is 1. So 1 into gravity plus half into gravity plus 1 by 4 into gravity plus 1 by 8 into gravity, and so on and so forth, divided by 1 square by m1 plus half square by m2 plus 1 by 4 square by m3, and so on and so forth. So you can see you have found out the value of tension in just one shot. It's a very nice question. So just you have written the value of the tension in one shot. Suppose you have been given the value of m1, m2, m3, so you will be able to write the value of the tension. In the numerator, it is an infinite GP, and in the denominator also, you will be able to write the value of tension very, very easily, right? Sorry, you can find out the value of the denominator if we know the value of m1, m2, m3. Suppose m1 equals to m2 equals to m3, then this will also convert into an infinite GP, and we will be able to find the value of the tension. See, don't focus on the mathematics part. Just look what I am doing. Okay, let me take one more question. So here, if you see, so here the gravity is the block m1 is going to accelerate on this axis. So what is the gravity here? G sine theta. It's not G, it's G sine theta. So let's say tension is T over here. So what will be tension here? T by 2. And here also tension will be T by 2. So how to write the value of T? Very simple. Here it is 1. So 1 into G sine theta, right? Plus half into, this is going to accelerate on y axis. So gravity will appear fully. So half into gravity plus half into gravity, divided by 1 square by m1 plus half square by m2 plus half square by m3. So this will be the value of the tension. You can see very how fast we are doing. Again, let's just one more question and then I'll come to the explanation. I have taken so many questions so as to make you guys understand that what we are doing, and then I will come to why part. So by now you would have been, if you would have been doing these kind of questions, let's say by writing equations and all those things, and by now you would have been simply thrilled or might be disturbed as well ki how are we doing this. I will tell you the explanation very shortly. So again, let's say tension is T over here. So it will be T. So what will be tension over here? 2T. You can see, because in this string the tension will become 2T, right? So how to find the value of the tension? Let's see. So what is the number written just beside tension? So it's 1. So it's like 1 into gravity, because gravity will act fully along the y-axis. Here also gravity will act fully along the y-axis. So here also 1 into gravity. Here gravity acts along y-axis, but the string is along x-axis. So no component of gravity will come along here. Okay. So here 2 into 0 you can write. 2 into 0 divide by 1 square by m2. So this was m2. So 1 square by m2 plus 1 square by m3 plus 2 square by m1. So guys, just quickly write yes if you have understood the what part. I am not talking about the explanation. Of course, I have still not explained. So did you understand that what we are doing? That how to write the value of the tension? Just quickly write in your chat box, in your chat. Then I will come to the explanation that why we are doing this, or how I am going to write it. How am I writing the tension? So just a quick yes in your chats, which will allow me to proceed. So I hope you have understood. Good, Gaurav. So I hope you have understood that what we are doing. That means what exactly how to write the value of the tension. Now let us see, why is this formula working, or more importantly, when will this formula not work? Is it going to work in all possible situations? Of course not. It is not going to work in all possible situations. There are certain situations wherein this formula will not work. So for understanding those kind of stuff, we will have to see the proof of it. Okay, so like how did I get to this? Why am I writing this? So let's quickly see. So I've taken this question, the first question. If you uh, if you see, this was the first question that I did using the tension formula. Okay, and what result did I get? So again, if you want to go back, if you just want to go back and check, so this was the value of the tension that I wrote. Okay, G plus G, that means it was effectively 4G divided by 1 by m3 plus 1 by m2 plus 4 by m1. This is what I had written. Okay, now let's go to the proof of it. Let's go to the proof of it. Okay. Now see, what I'm saying is, if I ask you to do this question fundamentally, okay, basically, if I ask you that do this question fundamentally, okay, that means suppose you are in class 11th and this has been given to you as a homework, do this question fundamentally. How would you do this? By writing Newton's laws equation. What would you have done? What would you have done, right? So I would have assumed this acceleration to be, let us say, a1, this acceleration to be, let us say, a2. So I'm going to do this question fundamentally now, which will also help you to understand how tension formula comes. This will help you understand how tension formula comes, guys. Be very careful. What am I doing? Okay, I hope that you will be able to do this question fundamentally. That is the least I can expect. So now I have assumed the acceleration of m1 as a1, and acceleration of m2 as a2, and the acceleration of m3 as a3. What is the value of force? So let's say, in which part I had assumed tension T. So if you see, I had assumed tension T in the bottom string and 2T in the top string. So basically same thing I'm going to do over here. I'm assuming tension T in the bottom string, let us say. So these are the tension T over here, and here the tension I'm assuming 2T. Okay, so for the bottom string, so for the first M1, will I write? Mg minus tension. So that means this will be M1g minus 2 into tension. Look at this 2 very carefully. So magic lies in this 2. So M1g minus 2t is equals to M1 A1, right? This is the equation I would have made for M1. What about M2? I would have written M2G minus tension. So that means I would have done M2G minus tension. I am writing 1 into tension deliberately because I want to show you how this one will come into picture. That means what happens to this one. Okay, so basically look at it. M2G minus 1 into T is equals to, I would have written M2 into A2. This I would have written, right? And similarly for M3, what would I have done? I would have done M3G minus 1 into tension. That would have been equals to M3 into A3. That I would have written, right? So this will allow me to write, if you divide this whole equation by m1, so this will become g minus 2t by m1. That will be is equals to a1. Okay, what happens on this? So this will allow me to write g minus 1 into t by m2. That will be is equals to a2, right? And this will allow me to write g minus 1 into t divided by m3. That will be is equals to a3. So these are the values of A1, A2, and A3. Now, how will you write the constraint? So using the virtual work method, I hope you know the virtual work method or virtual power method, whatever you want to call it, that the tension is not going to deliver any power. So basically, if you multiply, that means what will happen? Minus 2t into A1. That means minus 2t into A1. Here minus t into A2. So I hope you know this, that this is called power method. So minus t into A3. That will come out to be 0. So I'm writing this here as 1 into t and here also 1 into t. So minus 2t into a1, minus t into a2 and minus t into a3, that will be 0. So here minus t will go into 0. So you can see this becomes 2a1 plus this 1 is left, here 2 is left. So you can see this 2 is left. Here 2 will not go into 0. Only t will go into 0. So 2a1 plus 1 into a2 plus 1 into a3 becomes 0. So here also if you see now, this 2 comes into picture because of this 2. Here tension had a coefficient of 2, so which has come over here. Here tension had a coefficient of 1, which has come over here. And here tension has a coefficient of 1, which again has come over here, right? Now basically again this minus has gone into 0, so this 2 is left out. T has also gone into 0, so 2 is left out, 1 is left out, and 1 is left out. Now what you have to do, just put the value of a1 here. So if you put the value of a1 here, now pay attention because now is the time which will help you understand how did we get this formula, right? So just put the value of a1 here. So if I put the value of a1 here, so 2 was present already. This g minus this 2t. So 2t will be written as it is, and by m1, okay, plus 1 into a2. A2 value is this. So you can see g minus 1 into t by m2. And again, if you see 1 into a3. So what is a3? A3 is this. So which is g minus 1 into t by m3 equals to 0. Now see guys, this becomes 2 into g, this becomes 1 into g, and this becomes 1 into g, right? And this will become 2 square into t by m1. Okay, so I'm taking that whole thing on the right side of 0. That means this will become 2 into t by m1. This will become 1 into 1 into t by m2. And this will become 1 into 1 into t by m3. So all those, since there is a minus sign, so all those things will come on the RHS where 0 was present. So this will become 2 square t by m1 plus 1 square t by m2 plus 1 square t by m3. So here if you see value of tension, what I'm writing over here, the value of the tension. If you look carefully, then exactly the same result that I had told you. 2g plus 1g plus 1g. 2g plus 1g plus 1g divided by 2 square by m1 plus 1 square by m2 plus 1 square by m3. That means 2 square by m1 plus 1 square by m2 plus 1 square by m3. So this is the value of the tension that I have found out. This is the value of tension that I have found out, and I had told you exactly. So guys, I think you would be able to appreciate this was exactly I had told you 2 into G for M1 and 1 into G for M2 and 1 into G for M3 divided by 2 square by M1 plus 1 square by M2 plus 1 square by M3. Basically, if you think carefully, what has happened? See, how did you get, see, basically in this equation, in this part, if you divide this by M1, so tension ka coefficient appears only in this, in these terms. That means 2T by M1, 1T by M2 and 1T by M3. Sorry. So the tension ka coefficient appears here, 2, 1, 1. And when you write the constraint equation using the virtual work or virtual power, so again tension goes into zero, T goes into zero, but it leaves its coefficient. That means if you see carefully here, 2 was left, here 1 was left, and here also 1 was left. So tension goes into zero after leaving its coefficient, right? And when you put the value of A1 here, suppose I put the value of A1 here. So what happens? This 2, which was left by this tension, gets multiplied by this gravity. And this 2 gets multiplied by this 2. So that means this becomes 2 square. Similarly, this one gets multiplied by this gravity. And this one gets multiplied by this one. So that means it becomes 1 square. Similarly, this one gets multiplied by this gravity, and this one gets multiplied by this one. So that means you get 1 square. So, so what do you get overall? So you get 2G, 1G and 1G, 2G, 1G and 1G, and you get 2 square by M1 plus 1 square by M2 plus 1 square by M3 whole multiplied by tension. So exactly that is why I had told you to write the tension in this manner. 2G. So basically 2 into gravity, 1 into gravity, 1 into gravity, divide by 2 square by M1 plus 1 square by M2 plus 1 square by M3. I hope guys you would have understood. I hope you would have realized that why, just a quick yes on the chat. You know, if you understood, why did I tell you to write the tension in this format? Because eventually you're going to get this type of expression. Did you understand this? Just a quick yes. I'll give you some more explanations over here. Did you understand this, guys? Why did we write the tension in this manner? Yes, Gaurav, did you understand? Now, basically, so if you let's talk about this. Let's talk about this one. Why did we write the tension in this format? Like that means, what would you have done if you have written, if you would have written the equation? If you would have written the equation, suppose here I am writing the expression as A1, here I am writing the expression as A2, and here I am writing the expression as A3. How would I have done this question fundamentally? I would have written m1g sine theta, this is the force along this axis, minus t, minus 1 into t is equals to m1 a1. This I would have written for this block. For the second block, what would I have written? m2g minus t by 2. m2g minus t by 2. That means half into t. That would have been equals to m2 into a2, right? And for the third case, I would have written m3g minus t by 2. m3g minus half into t. That would have been equals to m3 into a3. So you can see that here also, just in the first case, gravity has been replaced by g sine theta, because the force on this axis is not mg, it is mg sine theta. That is why I had said to replace g by g sine theta in the original expression. Apart from this, the constraint equation will remain as it is. 1 into t, how will you write the constraint equation? So 1 into t into a1 minus 1 into t into a1. Because tension and acceleration are in opposite direction, so you will add a minus sign. Here also minus half into t into a2. So that means minus half into t into a2. And similarly for this, you will write minus half into t into a3. That will be equals to 0. So from here, you can see minus will go into 0 and t will go into 0. So you will be left with a1 plus a2 into half plus half into a3. That will be 0. So you can see in whole of this, just for the m1 part, g has been replaced by g sine theta. So which is what I told you, to replace this g by g sine theta, everything else remains the same. So that is why this is the result that you can expect finally. So I hope guys you would have understood, you would have realized, or you would have understood the power of this method. It's a very nice method. It's a beautiful method which is called tension formula. Okay. So if you practice this using, if you practice questions using this formula, then you will be saved with lot of time. Lot of time will be saved for you. You know, instead of doing the question in a long way, you will be able to do question in much shorter format. Right now, I will tell you some of the checklist wherein which you should always check before using this, because this will not be always applicable. So I have made some checklist on my own. See, this method is not given in any book and something. So basically, I have tried to made this checklist using like the questions that I have dealt with in these many years. So this might not be the exhaustive checklist. You can see there I've put a disclaimer over here. Okay, star mark. So you can see, you would know that there, whenever you want to put a disclaimer, you can always put some star mark. So this is the star mark that I have put. So if you find any of this happening in the question, then you should not use tension formula. Okay. So what is the first thing you should check? If the tension in the whole system should be representable in the single variable only. If there are more than two variables like T1, T2, then they avoid this method. That means, see, in this all the questions that I took, tension was representable in T only. It's fine to have 2T, 1T, half T, 3T, 4T, it's okay. But T1, T2, T3, that means different tensions, that should not, that is not allowed. For example, suppose I give you an example. Suppose we have this kind of situation. Okay, suppose this is block M1, this is a pulley. Okay, and let us say this is another block which is M. Okay, this pulley is connected to the ceiling, and we have one more uh, string, and basically let's say this is M2, right? Now, if so what I'm saying here, you can see there are two strings involved. So if the tension here is T1, so it will be T2 over here. So in that case, you should not use this rule. So remember, it's okay to have T, 2T, 4T, but you should not have T1, T2 in this kind of situation. Please do remember this. There should not be friction anywhere. So friction also should be not present for our tension formula to work. If you remember, I have, while using the derivation, while deriving this, the friction was not taken into account. So friction is present. Ideally, you should avoid this. All strings and pulley must be ideal. That means there should not be any rotation of pulley. The moment of inertia and all those things should be zero. Pulley should not be, frictional. Pulley should not have any friction. It should not rotate. So ideal situations must be present. Do remember this. Acceleration of each block should be along the string only. This is a very, very important point. So remember that acceleration of each block should be along the string. That means if you see all the cases, acceleration of each block was happening along the string. That means this block was accelerating along this string. This block was accelerating along this string. This block was also accelerating along this string. Here also, all the blocks were accelerating along this string. If you see, this block was accelerating along this string, this block was accelerating along this string. Okay, so here also this block was accelerating along this string. Okay, here also this block was accelerating along this string, right? So here also this block was accelerating, the horizontal block was accelerating along this string. So remember that uh, there should not be a case wherein block is not accelerating along this, not there should not be a case wherein block is accelerating not along the string. For example, I can show you a scenario. Suppose there is a block M, okay, and let us say pulley is like this, okay. So let's say this is M2, and let us say so this kind of situation. So here, if you see, the acceleration of block will be along this axis, okay, whereas the string is along this axis. So string is slanted, and the block is accelerating along the x-axis. So the acceleration of the block is not along the string. So remember that this formula should not be used in such a case. I hope you would have understood. So, and see, if you have any doubt that when can you use this formula, then it's better to avoid. Okay, do by fundamentals. If you are perfectly sure that this formula is applicable, then only do it. So, what is the thumb rule? See, like if you want to be sure that this formula can be used, think of the situation. How would you have done this question fundamentally? So, if you think in mind that how would you have done this question fundamentally, and in by fundamentally, if you are able to write this equation, that means the starting equations are of this format: mg minus some tension is equals to ma, mg minus some tension equals to ma. If this equations of forces, equations of Newton's laws on each block are of this format, and the constraint is of this format, then eventually the result will be of also of this format. So basically, the ideal rule is that if you think that if you do the question fundamentally and the starting equations are going to be of which are the equations of Newton's laws of motion. So those equations, if they are of the similar format which I have made here while deriving this formula, and the constraint also which you would be writing for your question is of this format which I have written here for while deriving this formula, then the eventual result definitely will also be of the final format of the tension which I have told you. So, guys, I hope you would have understood this amazing method of writing the tension. This is called tension formula, right? Now, let's again go to the second concept, which is very, very powerful concept, a beautiful concept. This is a very, very helpful concept of average. Okay, it is not physics. Basically, it is simple aptitude, which can be applied in different questions of physics. So, I will not be talking about physics. Rather, I will talk about the situations in which physics is present. But the concept per se is not a concept of physics. It's a concept which is of simple aptitude, which is definitely applicable in many possible situations and many questions, even of the JEE Advanced level as well. So you can use this, you can see this, okay. You can apply this method in different questions of physics, okay. Now, I before doing the actual JEE questions, let me tell you, okay, key let me ask you a very, very simple question. Let me ask you a very, very simple question. Suppose there's a person. Okay, suppose there's a person who is moving like this. So from zero to suppose he's moving along x-axis. So from 0 to 2 seconds. That means from 0 to 2 seconds. Okay, he moves. Let us say at 4 meter per second. Okay, then from 2 to 4 seconds. Okay, let's say he moves at 5 meter per second. Okay, then from 4 to 6 seconds, right? So he moves at, let's say, 6 meter per second, and let's say from 6 to 8 seconds he moves at 7 meter per second, and from 8 to 10 seconds he moves at, let's say, 8 meter per second, right? So if I ask you the displacement of this man in 10 seconds, so for the first 2 seconds he was moving at 4 meter per second, for the next 2 seconds, he was moving at 5 meter per second. For the next 2 seconds, he was moving at 6. For the next 2 seconds, he was 7. And for the last 2 seconds, he was moving at 8 meter per second. If I ask you the displacement of this man, a very simple case will be one of the way which I can tell you is, of course, all of you will be knowing, is that multiplies this 2 second with 4, then multiply this 2 second by 5, then multiply this 2 second by 6, then multiply this 2 second by 7, and then multiply this 2 second by 8. So if you add it up, what will be your answer? Your answer will be simply 60. Okay, you can do this. This is 8 to the 16 plus 8 24 34 plus 12 46 plus 14 60. Okay, now what you have done, you have simply multiplied by the respective time by the respective velocity and added it up for the whole duration. Is there any other way by which we can we can solve this question very, very fast? So I think जो है Abhinand, you have figured out. So the this can be taken as the average velocity of the whole duration. You can figure out as if this 6 meter per second is the average velocity of the whole duration. So indeed, you can multiply simply 6 by the whole time 10 seconds. This will be 60. So what did you do over here? You simply multiplied 6 by 10. Why did you do this? Because you could see the pattern that velocity was increasing along a pattern, and the displacement for finding the displacement, we can simply say that 6 can be taken as the average, because whatever the distance was lost for the first 2 seconds was compensated in the last 2 seconds. That means I'm saying that since the particle or the man was moving at a less velocity for the first 2 seconds, so it is also moving at a high velocity in last 2 seconds. So average of 8 and 4 comes out to be 6. Similarly, if you see over here in this duration, in this slot, the whatever the distance has been lost because of less velocity uh, is compensated by moving at a higher velocity in this slot. So if I take 6 as a benchmark, 5 and 7 will average out because time is same, 2 seconds. Similarly, 4 and 8 will average out because time is same, 2 seconds. So this gives you a simple method wherein you can multiply this 6 by the whole time 10 and you will get your answer. Right? Now this I am sure all of you would have understood. Let me take one more scenario. Suppose I have got 5 particles, each of mass 1 kg. So this is 1 kg, this is also 1 kg, this is also 1 kg, this is also 1 kg, and this is also 1 kg. Right? Suppose this moves at 1 meter per second, this moves at 2 meter per second, this moves at 3 meter per second, this moves at 4 meter per second, and this moves at 5 meter per second. If I ask you to find the linear momentum of the system, all of them are moving along positive y-axis. If I ask you to find the linear momentum of the system, one way would be to simply multiply the masses by their velocity. So 1 into 1 plus 1 into 2 plus 1 into 3 plus 1 into 4 plus 1 into 5. So this will be linear momentum of the system, which will be nothing but 15, which will be nothing but 15. Okay. Now, if you think carefully, can I also take that 3 meter per second to be the effective velocity of all the particles for the purpose of finding the linear momentum? Be very careful here. I am not saying that you can find any random quantity by using this method. But since linear momentum is a directly proportional to velocity. Momentum is directly proportional to velocity. Okay. So, and velocity was varying linearly. Velocity was varying linearly. So we can say that linear momentum will also vary linearly. That means this particle will have the lowest linear momentum, this particle will have the highest linear momentum, and the variation will be kind of linear. Okay. So that means I can see that this middle one will be sort of average of extreme particles. Okay, or the particles which are at equidistance from the middle one. So that means if you find the average of momentum of 2 and 4, then 3 will be the average linear moment. 3 will it will come out to be the momentum of 3. If you find the average of linear momentum of 2 and 4, so it will come out to be same as that of this middle particle. So that is why we could have done like we could have taken 3 as the effective velocity. So what I could have done simply I would have assumed that all the particles which are of 5 kg total system is of 5 kg and effectively they are multiplying by 3. So answer will be 15. So I hope you would have understood what I am trying to tell you here is that since the velocity was linear, remember this is a very important statement, since the velocity was varying linearly and the momentum is directly proportional to velocity, therefore I can take the average velocity, that means the velocity of the middle particle, to be the effective velocity of whole system for the purpose of finding linear momentum. Be very careful. Same cannot be said for kinetic energy because kinetic energy is half mv square. Remember, so kinetic energy has a square proportionality with velocity. Now velocity is still linear for this system, but kinetic energy will not vary linearly. Remember, kinetic energy, if you move along this axis, kinetic energy will not vary linearly. It will be a parabolic function. So you cannot say that the kinetic energy of the whole system will be simply half into mass of the system multiplied by 3 square. That will be a wrong thing to say. I hope you are understanding. You cannot say kinetic energy of the whole system will be half into total mass into 3 square. 3 is the effective velocity. For the linear momentum, we could do that. But for the kinetic energy, we cannot do that. I hope guys you are understanding this is a very, very important and very, very mind-blowing method, powerful method. If you understand the grasp of it, you will be able to do many, many JEE advanced level questions with like just by thinking without using integration, without using long methods, right? So again, I'll tell you why couldn't I write the kinetic energy? Because kinetic energy is a square function of velocity. Velocity is still a linear variation over here, but kinetic energy is a square function of velocity. So we cannot write the kinetic energy in the same manner the way we wrote. linear momentum. Now, I hope so. The basic idea becomes, if the quantity that we are trying to calculate, okay, if the quantity that we are trying to calculate has a linear variation. So here the linear momentum had a linear variation. Linear momentum had a linear variation. Okay, then we can use the concept of average. Then we can use the concept of average. The kinetic energy, if we want to calculate the kinetic energy, we will have to resort to the fundamental method. We cannot use the average method because kinetic energy is not varying linearly. Okay, so using this concept, let us do some questions which you would have done using integration, so guys, please pay attention over here. uh, let's see if we can apply the average method or not. If you think what is happening over here, a rectangular loop ABCD is placed in XY plane. So basically this is XY plane. Let's say this is X axis, this is Y axis, and this is a rectangular loop. Okay, so its coordinates, the end point, the coordinates of the vertices, has been given. So this is 0 comma 0. Okay, so let's call this as A. Okay, let's call this as B. So the coordinate of this is P comma 0. Okay, the coordinate of this is as 0 comma Q, right? 0 comma Q will be this one, sorry, my bad. This will be 0 comma Q, and this will be P comma Q, right? So this will be P comma Q, right? So this whole thing is, this x-axis is having a length of P. You can easily see that this length is P, and you can see that this length is Q, right? Now, what I'm saying is, here the here the magnetic field, if you can see, it is directed perpendicular to the xy plane. That means, let us assume that magnetic field is going inside the screen plane. It can go inside or it can come outside. It is not specified. Let us assume that magnetic field is going inside. Okay, but the variation is b naught x. Now this is very very important. If you see the magnetic field ka variation, so it is b naught into x. What does this imply? Here the magnetic field will also almost be zero along the y-axis. Since the x is zero, so magnetic field will be zero. Here the magnetic field will increase slightly on this vertical strip. Here this magnetic field will again increase slightly more because the x coordinate has increased. At the middle, the magnetic field would have become b naught into p by 2 because this length is p. So if the middle, for the middle strip, this strip which is at the equidistance from A and B, the x coordinate would have become p by 2. So the magnetic field would have become b naught into p by 2, right? If you go further along the along this axis, then magnetic field will still become like more, and the increment is, you can see that it is happening linearly. Magnetic field is increasing linearly, and at the last vertical strip, magnetic field would have become b naught into p. Okay, now, okay, we have understood that magnetic field increases linearly if we move along the x-axis. If we move along the x-axis, then magnetic field increases linearly. This we have understood, right? Now we have to find the flux. Remember, we have to find the flux. So think whether the flux is increasing linearly or not, whether the flux variation is linear or not. Think like that. So if you consider this particular strip, so how would you have written the flux here? You would have written simply the magnetic field at this location multiplied by area dA, right? If you, if I ask you the flux for this strip, how would you have written the flux here? Flux would have been simply the magnetic field at this location multiplied by the area dA, right? If I ask you the flux for this strip, how would you have written? Magnetic field at this location multiplied by area dA, right? If I ask you the flux for this location, how would you have written? Magnetic field at this location multiplied by area dA, right? Now, since magnetic field is increasing linearly, whereas dA remains same, dA remains equal for all the strip, this means that flux is also increasing linearly. That means the flux for this strip will be zero almost. If you go ahead, then flux will increase slightly. If you move further, flux will increase again slightly. For this part, flux will be even more. The highest flux will happen for this strip, and this variation will be linear because you can say that d phi is nothing but b into dA, and this b is increasing linearly. So d phi is proportional to b. So b is increasing linearly. Hence, you can use the concept of average. So just take the middle point. Just you can think that the magnetic field at the middle point. What is the magnetic field at the middle point? So put x is equals to p by 2. So B average will be B naught into p by 2. So this is the magnetic field. This will act as the effective magnetic field for whole rectangular loop. So we can straight away write flux as B average into area of the loop. That means B naught into p by 2 multiplied by area of the loop, which is PQ. So without integration, we have solved this question. I hope guys you would have understood. I can see that uh, that Abhinand, you have given the correct answer. So good job, brother. Very nice. So B naught P square by 2 into Q. So this was the effective use of average method. I have taken many questions illustrating this average method. Let's see few more questions. Okay. So I'm sure that you would have done this question if you have prepared for JEE or mains or advanced, then you would have definitely seen this question. The question says that this is a rope, this is a smooth rope of length L and the cross section area is A. So basically by cross section they mean this area which is A. So this area is the cross section area. Young's modulus of the rope is Y and they are pulled by force F1 and F2. So you can see there's a force F1 acting towards the right and the force F2 acting towards the left, and F1 is greater given more than F2. You have to find the elongation in the wire. Okay, you have to find the elongation in the wire. Okay, now I don't know if you have done this question or not, but generally speaking, many students do this question by integration. They go at distance x, they take element dx. Okay, they take element dx and they write the stress in that element, and then they write the strain, and then they use stress by strain equals to Young's modulus, and they integrate. Okay, now can we do this question by average without integrating, just by simple logic? So the answer is yes. Let's see if the tension, I hope you know that in this case, this is taught in Newton's law, that the tension at this part will effectively become T2. The force with which you are pulling the rope is the same force by which rope is going to pull you. So the T2 is you are pulling the rope by the force F2. So rope is also going to pull you by the force F2. Newton's third law. Similarly, here also the tension will be T1 because you are pulling the rope by, sorry, T1 will be, so my bad, this tension will be F2. This tension will be F2. So T will be equals to F2 here, and here T will be equals to F1. Okay, value of the tension will be equals to F1, right? So the tension is F1 here and tension is F2 here. The variation of the tension will be linear. I hope you know this. This is taught in Newton's law. So I'm sure that you should be able to understand. If you do not know, or if you're not convinced why the tension will be linear, then I can very simply tell you. I can simply show you how to write that. If you think logically, then you can arrive at the conclusion that tension has to be linear. But if you're not convinced, then I can prove it very easily. Suppose, so what will be the acceleration of this rope? So acceleration of this rope will be, you can see, let me hold on. So acceleration of this rope will be F2 minus F1, F1 minus F2, sorry, F1 minus F2 by M, right? Let's say M is the mass of the rope. So F1 minus F2 by M. I'm assuming M to be the mass of the rope. So this will be the acceleration of the rope. Okay. Now, if I assume if I go at distance X, and if I assume the tension T over here, if I assume the tension T over here, so look at this part of the rope, this part. Okay, look at this part of the rope. The tension is acting at tension is T, and it will act in the rightward direction. So let's call this length to be X. So what will be the mass of this rope? So mass of this rope will be M by L into X. This will be the mass of this rope, mass per unit length multiplied by the length of this part. Okay. So what will be the force equation that you are going to write on this? Very simple. Tension minus force. So tension minus, so here F2 force was acting, remember? So tension minus F2 will be is equals to mass into acceleration. So mass is M by Lx into acceleration. Acceleration, if you can see, so I had found F1 minus F2 by M, right? So here M and M will get cancelled. So you can see that variation of tension has come out to be linear, F1 minus F2 by L into X. So you can see that F2 is a constant, this is also constant. So tension is varying linearly with X. I think you should have understood that. Very, very obvious. It's a very obvious statement. The, the point not, here is not that like whether tension is linear or not. Of course, everybody knows that in this case, tension comes out to be linear. But the point is to think how we can apply average method for finding the elongation. So let me illustrate this. So since we have already understood that tension is linear, okay, and the value of the tension at this point is F2, remember, and the value of the tension at this point is F1, okay. Now, you know that this elongation, what is elongation? Elongation is extension upon original length. Suppose I take the element dx here. Suppose I take the element dx at a distance of x. I'm not using integration. I'm just trying to explain why we can use average method here. Okay. So basically, suppose I'm taking an element of dx at a distance of x. Okay. And let's say elongation in this element is dl. Let us say elongation in this element is dl. So what would have been the strain dl by dx? dl by dx would have been the strain, right? This you would have written equals to, so y Young's modulus multiplied by strain would have been equals to tension at this location divided by cross sectional area, right? Now this is the magic. If you see dx for each part is same, for that means for this part dx is same, for this part dx is same, for this part dx is same. So for every element dx is same, every element dx is same. Young's modulus of each element is also same. Cross sectional area for each element is also same. Only tension varies linearly. Tension goes on increasing linearly. So which will make the elongation increase linearly, because from here you should be able to realize that the dl is a linear function. Dl is directly proportional to tension. Dl you can see is the elongation in a small in this element. So elongation in this element is directly proportional to the tension. You should be able to understand this. So since tension increases linearly, hence the elongation also will increase linearly. That means for this part, for the leftmost part, the elongation will be minimum because the tension is minimum. Whereas in this part, the elongation will be maximum since the tension is maximum. And the variation will be linear. This is a very, very critical analysis. Hence, we can say that you can use the average tension, which was the tension at the midpoint. So the since the variation of the tension is linear, so we can say that average tension at the midpoint will be simply F1 plus F2 by 2. F1 plus F2 by 2. This will be the average value of the tension, which you can assume to be constant throughout for the purpose of evaluation of elongation. You cannot assume tension to be this for the anything. For example, for elastic energy, you may not assume this. For calculation of elastic energy, you will have to check whether elastic energy in each element is varying linearly or not. So it will not be a linear variation. So you cannot say that average tension will be will be this, and you cannot use this. But for the purpose of evaluation of elongation, you can use this. Why? Because as I told you, the quantity that we are trying to calculate, that should vary linearly. If you think I had written this statement, if the quantity that we are trying to calculate has a linear variation, then you can use this type of method. So we are trying to calculate the elongation. So it was varying linearly. So we can use this as an average tension. Now you can see that F1 plus F2 by 2, this is the average tension upon cross-sectional area, which is A. That will be equals to Y into delta L, which is the elongation in the whole rope upon L. So from here delta L, you can calculate. It will come out to be L by L into F1 plus F2 into F1 plus F2 by 2 AY. So this will be the value of the uh, elongation. I hope you would have understood. I hope you would have gotten this. So it's an amazing, amazing technique. So this question I have again taken from Irodov, and I hope you would be able to understand now that many of the students I have seen that they do this question by integration. Many of them they use the equation of motion. But if you think very, very carefully, the question can be done just like in 5 seconds, just by using the concept of average. So if you think what is happening over here, a swimmer, there's a swimmer who can swim at 5 meter per second in still water, crosses the river with a river speed as v equals to y by d. So suppose here is a here's a river. Okay, the width of the river has been given to be d. So this is the width of the river. Now each, if you see, suppose the swimmer starts from this point, let's call this point to be origin, and this axis let's call to be y axis. Okay, and this axis we are calling as x axis. So what is happening over here? the uh, uh, the river velocity is a linear function of y. The river velocity is a linear function of y. That means the stream that is moving here will be moving almost at negligible velocity. This stream will be moving at slightly more velocity. This stream will be moving at slightly more velocity. This will be moving at further more velocity. And you can see that as I'm moving more and more along y-axis, the vectors, the y vectors are increasing. That means the velocity along the velocity of the river, the velocity along the river is increasing. Velocity of the river, sorry, not along the river. Velocity of the river is increasing. River stream is increasingly becoming flowing at a faster rate, and this variation is linear. Be careful, this variation is linear. Okay. Now, if person wants to cross the river in minimum time, so for crossing the river in minimum time, you know that a person has to apply all his efforts. That means he has to move his hands and legs along this y-axis. In that case, minimum time happens. I hope you know this. You have been taught this. So in this case, the person is moving at a speed of 5 meter per second and he's trying to move along y-axis. But because of river velocity, he will be slightly drifted along x-axis. I hope you understand this, right? So basically, if I ask you what will be time to cross the river, what will be the time to cross the river? So the river will be crossed if the displacement along y-axis becomes d. If the displacement along y-axis becomes d, and river is not going to contribute by pushing along y-axis. River was simply pushing along x-axis. So whatever velocity the person has got along y-axis, that will be simply d by 5. This will be the time in which the river will cross along x-axis. River will be crossed. This is the time in which river will be crossed. Okay. Now think carefully. So I can say that the y coordinate of the person, see y coordinate, not along the x coordinate. Y coordinate along the of the person is simply due to this 5, because river is just pushing along x-axis. River is not pushing the person along y-axis. River is just pushing along x-axis. So the y coordinate, that means the y displacement of the person, is simply this is happening because of his own velocity, which is 5. So y coordinate is simply linear function of time. We can say y coordinate of the person is simply 5t. And suppose person is at this point at any general time. Suppose person is at this point at any general time. So his x velocity will be just because of river. His x velocity will be just because of river. He is not going to push himself along x-axis. He is pushing himself only along y-axis. So the river velocity at this location is y by d, and the y is linear function of time, as you can see. So what do you understand? That the river velocity, that means which is also the x velocity of the person, which is also the x velocity of the person, becomes the linear function of time. Y, again, if you relate all the things, the y coordinate of the person was a linear function of time, because y coordinate is changing just because of his own velocity. River is not contributing anything along y axis. So y coordinate as a function of time will be simply 5t. Okay. And the river velocity was a linear function of y. So river velocity is also the velocity of the person along x-axis. So person ki x velocity, the x velocity of the person, becomes a linear function of time. So which we can write y by d, and y is nothing but 5 into t by d. Now this, look at this, very, very beautiful. From here, you can simply say that as time will move ahead, his velocity in x-axis will increase linearly, linear function of time. Okay. That means for the first second, he will move very slowly along x-axis. For the next second, he will move faster along x-axis. For the next second, he will move even more fast along x-axis. For the next second, he will move even more fast along x-axis. For the next second, he will move even more fast. So this thing will continue till the time he crosses the river. So for example, I'm just taking an example to make you understand. So for example, he starts at 0. So for the next second, he will move at 1. For the next second, he will move at 2. For the next second, he will move at 3 along the x-axis. Move at 4 along the x-axis. So remember the first question that I told you for the average method. Same pattern will be followed. So you can think that the average velocity will be the velocity which will happen at the mid, which will happen at exactly at the middle. So just put y as d by 2. Just put y as in this equation. Just put y as d by 2. So v average along x-axis will be, just put y as d by 2. That means that will be half. Okay, if you put y as d by 2, so it will become half, as simple as that. So what will be the x displacement? Simply drift, which you can call. So drift will be simply average velocity along the x-axis, which is half, multiplied by the time of crossing. Time of crossing we had written d by 5. So this will become d by 10. So this will be the drift of, in this case. I hope guys you would have understood. I hope you would have, you would be able to appreciate what we are doing. So this is a very, again, amazing method, why we can, or how we can use average concept in solving this particular question. Let's see more such scenarios. Okay, this particular question, if you read, at last I will explain you one more method for solving this question. Okay, if the time permits, then we will do this today, and if the time permits, then we will do this tomorrow in the second part. So this question can be done by much faster method. I will talk about that method later on. Okay, as I told you, if the time permits, then I will tell you that method today itself. If the time does not permit, then I will tell you that method tomorrow. But I'm going to definitely tell you that method. But before that, if you see this question, uh, what is happening over here? A solid cylinder of mass m, length L, and radius r is just immersed fully in river of density rho with its axis vertical. So that means if you draw the situation, suppose this is the river surface, and this is the cylinder whose, which is like this. Okay, cylinder is like this, and the length of the cylinder is L. Length of the cylinder is L, and radius of the cylinder is r. So you can see that radius is r, right? And the river is of density rho. So density of the river water is rho. The axis of the cylinder is vertical. Now an external agent pulls it out slowly. So suppose you are pulling it out very, very slowly. So you have to find the work done by the external agent. Okay, you have to find the work done by the external agent. This is the question. Okay, so cylinder is of mass m, length L, radius r. The external agent is pulling out very, very slowly. Okay, and you have to find the work done by the external agent. Okay, now effectively the question is of finding the work done by the buoyancy force. This is effective question. Let me explain, and then we will see how we can find the work done by the buoyancy force. So if I ask you how many forces are acting on the cylinder while it comes out, while think of the process of it coming outside. Think someone is pulling it slightly and slowly. So if I ask you how many forces are acting, so if you think rationally, so you will be able to come out with the number 3, that there are 3 forces acting. Of course, we are neglecting viscosity and we are neglecting the air resistance and everything. So there are 3 forces which are acting. External agent force, the force which is applied by the external agent, gravity, and buoyancy force. Okay, so there are 3 forces which are acting. Now, according to work energy theorem, what you can say? You should say that work done by all the forces equals to change in the kinetic energy. This is what work energy theorem says, right? What is the final kinetic energy? 0. What is the initial kinetic energy? 0. Why it is 0? Because the external agent is always pulling out very slowly. That means he is just moving his hands at a very, very low pace. It's like at a speed of ant, very, very slowly, like this. So you can think that almost the kinetic energy is 0 at all times. Okay, so basically there is no change in the kinetic energy because it was initially 0 and it will remain 0 whatsoever, right? So we can say that work done by external agent plus work done by gravity plus work done by buoyancy force equals to delta K, right? Which will be equals to 0. Delta K is simply 0 here. Now, work done by gravity is simply, you can say, mg into height risen by center of mass. Okay, and you can see that the work done by gravity is negative because gravity acts downwards and body moves upwards. So, if you draw the final situation, the cylinder will look like this. After coming out, cylinder will look like this, right? You can see the center of the mass was initially here, and finally it has moved upwards. So you can see that center of mass has moved by a distance of L. Okay. So what is the work done by gravity? Very simple. Work done by gravity is simply minus mgl, right? This is the work done by gravity. So as I told you, the question is effectively to find the work done by the Buoyancy force. This is the effective value of the effective question. Because the moment we are able to find the work done by the Buoyancy force, we will be able to find the we will be able to write the work done by the external agent. Okay. Now, for finding the work done by the Buoyancy force, many of you would resort to integration. Okay, you will. I'll tell you how most of the students will do this. You will assume that it cylinder has come out by a distance of y at a regional moment, and you will further push it by a distance dy. So you will write the Buoyancy force at this moment, and you will write the small work done when the cylinder goes further by dy. Okay, so you will write the work done by the Buoyancy force, and you will integrate this for the whole process. That means cylinder for coming from initial, that means initial situation to final situation. You will integrate this. So that is the way you will do this. Okay, you will get your answer definitely. Let me tell you, this question can be done without integration by using the average method. Also, as I told you, there is one more even faster method, which we will, as I told you, we will see later on. But first, let's do this by average. Okay. Now, imagine why can we apply average? Let's try to figure out why can we apply average over here. Okay. So, how do you write work done? So, suppose basically this is the cylinder. Okay, this is the cylinder. Okay. So, think right now, see, basically Buoyancy force acts. How will you write Buoyancy force? Suppose, let me show you the scenario. Suppose this is the surface of the water, and let's say this is the uh, suppose this much length is left. This much length is left. Okay, that means L minus y length has been taken out. L minus y length has been taken out. So you can see the Buoyancy force you will write at this moment will be the area of the cross section A. This area is A multiplied by Y. So this is the volume of the body displaced, volume of the water displaced, volume of the liquid displaced, multiplied by density of water. So this will become Buoyancy mass and multiplied by gravity. So you can see the Buoyancy force is a linear function of Y. You can see the Buoyancy force is the linear function of Y. Okay. And it is going to decrease linearly. It is going to decrease linearly. If you think carefully, it is going to decrease linearly, right? Now, so Buoyancy force starts from a large. Suppose right now the Buoyancy force is 10. Suppose right now the Buoyancy force is 10. Okay, right now I am taking a number so that you can understand. Suppose right now the Buoyancy force is 10. So let's take it out dy. So how much work Buoyancy force has done? 10 dy. Now Buoyancy force decreases slightly. Okay, so this much body has come out. Now again point force, let us say it becomes 9.9, and you take it further out dy. So how much Buoyancy force does the work? 9.9 dy. Okay, now again this much body has come out, and let's say point force has decreased slightly and it has become 9.8, and you further take it out dy. So how much work point force does again? 9.8 dy. So again let's say this much body has come out, so point force has become 9.7. Again you further pull it dy. So can you see what is happening? This will go down until Buoyancy force becomes 0. And so if you see carefully what is happening, Buoyancy force is decreasing linearly, which also makes work done decrease linearly. For the first part, the work done was 10 dy, then it was 9.9 dy, then it was 9.8 dy, then it was 9.7 dy. So can we say that the average work, it's like you can think that 10 and 0 average is 5. 9.9 and point 0.1, here point 0.1 will also happen, point 0.2 will also happen, point 0.3 will also happen. So 9.9 and point 0.1 ka average is also 5. 9.8 and point 0.3 ka average is also 5. 9 9.8 point 2 ka average is also 5. 9.7 point 0.3 ka average is also 5. So can you imagine, like, are you able to understand that, we can imagine, we can feel as if half of this buoyant force was acting throughout. That means you can see, if you take this and this together, so you can say that only 5 Newton was acting for the first dy and 5 Newton was acting as the last dy. That means 5 dy, 5 dy. So you can see these two will still, if you add these two, 10 dy and 0 dy, and if you add these two, it will again be same. Same for this 9.9 dy and point 0.1 dy. So here you also you can see 5 dy, 5 dy. So if you add 9.9 dy and zero point 0.1 dy, again you will get 5 plus 5 10. So again, if you see 9.8 and point 0.2, so you can see 5 dy and 5 dy. So what I'm trying to explain is, you can imagine as if the throughout this pulling out of cylinder, throughout this process of pulling, only half the buoyant force was acting. That means as if half of the cylinder was always inside and half of the cylinder was always outside. You can imagine like this. I hope you are able to understand what I'm trying to tell you. Guys, please write yes on the chat if you are able to understand that what I'm telling you. It's a very powerful method. It's a very, very powerful method. So if you understood this, guys, then I can say that for the whole process, you can imagine as if half of the cylinder was fully inside. So now it's very simple. Throughout this pulling, you can imagine as if half of the cylinder was inside. So what is the average buoyant force? Simply A into L by 2. This is the half volume multiplied by density. This is rho, and multiplied by gravity. This is the value of the buoyant force throughout the motion, effective value of the buoyant force throughout the motion, and motion happens through distance of L. While you pull out, motion happens through a distance of L. So this is the value of the work done by the buoyant force, guys. And this will be positive because buoyant force acts in the upward direction and the body was also displacing in the upward direction. So buoyant force will do a positive work of this value. I hope you would have understood. I hope you would have appreciated the logic that without integration, we have been able to do this question without just, just by using common sense and logic. So the work done by the buoyant force now can be written as AL square rho g by 2. So you can put it over here. Work done by buoyant force is AL square rho g by 2. This is the work done by the buoyant force. So from here you can find the work done by the external agent, which is equals to minus work done by gravity and minus work done by buoyant force. So from here you can see the answer will be mgl minus AL square rho g by 2. So this will be the work done by the external agent. Question was effectively trying to find the work done by the external agent, which we have been able to find very, very elegantly. I hope you would have appreciated. I hope you would have understood this method. Okay. So again, I'm sure if you have prepared for JEE mains or advanced, you would have definitely seen this question and you would have definitely done this question. The question says that there's a cuboidal room of dimension L into B into H. So suppose this is the cuboidal room and it is filled till top. So this is the kind of the room we're talking about, and it is filled up till its top. So this is the scenario. My bad, again I'm wrong badly. Yes, so this kind of cuboidal room, right? So let's call this length to be L. Okay. Uh, so we have to. So let's call this length to be L rather. Hold on. Let's call this length to be L. Okay. Let's call this to be B. Okay. Let's call this to be H. It would hardly matter which what you want to call it. So I'm calling this as L, this to be B, and this to be H. Okay. The logic will remain the same. we have to ignore the atmosphere, and this is fully filled with liquid of density. It is not given. Let's assume density to be rho. So the liquid is of density rho and it is fully filled till top, and we have to find the force on this wall. Let's say we have to find the force on this wall. So I'm sure that you know that how to solve this question. You would have done by integration, as well as you would have remembered or memorized. If you have prepared for advanced, you would have memorized that. Write the pressure at middle point and multiply that by the whole area, right? Do you know this, guys? Just write yes on the chat box if you knew this, that you, and if you have done the same way, that taking the pressure at the middle point and multiplying this by area. Yes, how many of you uh, have done by this, right? So basically, again, the reason is why can you do this? So if you look at this wall L into B, if you look at this wall L into B, so why can you do this? Why this logic is correct? Okay, so the reason is again same, because if you move at a distance y, if you move at a distance y and take this type of strip, take this type of vertical strip, so the force acting on this df, the force acting on this strip df is nothing but pressure at this, which is y rho g, okay, multiplied by area, okay, which is nothing but L dy. Dy is the thickness of this strip, right? So if you move downwards, so you can see that area of the strips remains the same. Each strip has got the same area. There is no difference in the area of any strip whatsoever. But the pressure keeps on increasing linearly. So the pressure keeps on increasing linearly, but the area of the strip remains the same, which makes the force acting on this general strip at a distance y. If you talk about this strip at a distance y, so this force also starts increasing linearly because force is pressure into area. So the pressure increases linearly, area remains the same. So which also makes the force increasing linearly, which is what we wanted. If you remember the statement that I had written, the quantity that we are trying to calculate, the quantity that we are trying to calculate, that should be the linear function. So here we were trying to calculate the force, and that indeed becomes the linear function. Just we should be thrilled, and we can say that we can apply the average. So that is the reason you take the average pressure. That means the pressure at the middle. So pressure at the middle is nothing but B by 2 rho g. Okay, this is the average pressure. This is the average pressure. And what is the force now? So you can simply say that P average multiplied by the area. So area is nothing but L into B. So that is how you get the answer, rho g by 2 into LB square. So that is how you get this. I hope you would have understood the reason for writing this. This is a very, very famous question, which every JEE Advanced aspirant would have done, right? So, guys, I hope you have understood the concept of average. Try applying that in the different situations. There are many, many questions of JEE Advanced wherein you can apply that concept. Okay. Now, let's move to the concept number 3. This is again a very, very beautiful concept, a mind-blowing concept, which you would appreciate if you have done the question of collisions. And I'm sure that you would have been doing the question of collisions by writing the long equations. So I've taken one question just to illustrate that how will most of you solve this question if you ever get this in your exam. So the question says a very simple question per se, JEE Mains level question, very simple one, that how you have to find the velocities of each of the block. Here you can see there are two blocks, 4 kg and 1 kg. 4 kg is moving at 6 meter per second and 1 kg is moving at 1 meter per second. So you have to find the velocities of each block after the collision, and the restitution, coefficient of restitution is given as 0.5, right? So you have to find the velocity of each block after the collision. This is the question. Now, if I give you this question, then it's a very simple question. Let me draw the situation after the collision. Let us say that 4 kg moves at velocity v1 after the collision. Okay, and let's say 1 kg moves at v2 after the collision. So how generally or most of you will solve this question? Most of you how will solve this question? We will make two equations. One equation will be of momentum conservation, since there is no external force acting along the x-axis. So we can conserve the linear momentum. We are assuming the ground to be smooth. So we can conserve the linear momentum, and also we can write the coefficient of restitution equation. That is velocity of separation after the collision divided by velocity of approach before the collision. That is equals to coefficient of restitution. So these are the two equations that you are going to make, and using this you will be able to solve the question. So let's do this very fast. So what is the initial momentum? 4 into 6. This was the initial momentum of 4 kg plus 1 into 1. So these are the masses which are indicated inside the blocks. So 1 into 1, this is the initial momentum. That should be is equals to 4v1 plus 1v2. So this becomes 4v1 plus v2 comes out to be 25. This is the first equation that we would have made, right? Now, what is the second equation that we will make? So restitution, that is half, that will be is equals to velocity of separation, which is v2 minus v1 divided by velocity of approach. Approach was happening at 6 minus 1. So approach is the rate at which the distance between them is decreasing. So the 4 kg is moving at 6 and 1 kg was moving at 1. That means 6 minus 1. So that means v2 minus v1 upon 5. Hence we can say the second equation becomes v2 minus v1 is equals to 5 by 2. So very simple. If you deduct equation, so let's call this equation 1 and let's call this equation 2. So if you do equation 1 minus equation 2. So if you do equation 1 minus equation 2, v2 will cancel out and you will get 5v1. And that will be equals to 25 minus 2.5. So that will be 22.5, right? So v1 will come out to be 22.5 divided by 5. So I think this cancels with 5, right? 2.5, right? This comes out to be 4.5, I am assuming. So this is, I think, 4.5. Okay. And if this is 4.5, v1 is 4.5. So what is v2? So v2 will come out to be 4.5 plus 2.5. That means 7. So velocities of both the blocks we have found out very easily after the collision, writing two equations. Okay. Now, if I give you this question, then most of you will be able to do this. Most of you will be able to solve it using this method. Okay. Now, listen to me very carefully. I will tell you a method and I will also give you the explanation. I will give you the explanation at last. But first, I am going to tell you the method using which you can find the velocity. You can find the velocity of the like collision velocities after the collision very fast. That means without doing without writing any equation. You will be able to do that. Listen to me carefully, right? Okay. So before that, let's do some practice. Okay, let's do some practice. So suppose what I'm telling you. Suppose A is moving at 4 meter per second. Okay, I'm making you do the practice of center relative velocity because I want you to do the question very fast. So and let's say B is moving at 3 meter per second. 3 meter per second. So what is the velocity of A with respect to B? So velocity of A with respect to B is simply add it. So 4 plus 3, which is 7 meter per second in the right direction. Right direction. Okay, you know this. And velocity of B with respect to A is 7 meter per second in the left direction. Right? Left direction. So that is how you find relative velocity. I'm sure you know this, you know all of this. Okay. Now, one more thing. Suppose this train is moving at 3 meter per second and a person is moving at 4 meter per second with respect to train. Remember, velocity of the person with respect to train is 4 meter per second. You can see towards the right. So how will you find the velocity of the person in the ground frame? How will you find the velocity of the person in the ground frame? Simply add these two vectorially. So both of them are in the same direction. So add the velocity of the train to the velocity of the person in the train frame. Velocity of the person in the train frame is 4. So add this 4 plus 3. So this will become 7, right? So remember, if you have a velocity of any object in any frame. So here we had the velocity of the person in the train frame and we wanted to find the velocity of the person in the ground frame. What did we do? We added the velocity of the train to the velocity of the person. Of course, we did this vectorially. So since both of them are in the same direction, so 4 and 3 will get added up and it will become 7. Okay. So I hope you have understood this relative velocity concept, which I'm sure all of you would have been taught in class 11. Now I'll show you the steps for finding the velocity of collision, velocity of the collision, velocity of the blocks after the collision without writing the equation. So I've written down the steps. Just read them. You have to find the velocity of com, velocity of vcom, and then you have to come in the com frame. Okay, you have to find the velocity of center of mass. That means find the velocity of center of mass and then come in the com frame. I will show that how to do that. Then they write the velocities of each block in the com frame. Write the velocities of each block in the com frame. Remember. So what is the first step? Write the velocity of com and come in the com frame. Then in the com frame, write the velocities of each block. Okay, I will do that. Then you will understand. Then then multiply the velocities of each block which you have written in the com frame by the value of e and reverse the direction. Once you do that, you will have the velocities after the collision in the com frame. Then write the velocity in the ground frame. So again, let's quickly reiterate what we have to do. Find the velocity of com, go in the center of mass frame, write the velocity of each block in the com frame, multiply by e and reverse the direction of each velocities which you have written in the com frame. These will be the velocities after the collision in the com frame. Now write the velocities of the blocks in the ground frame since you know the velocity of the com. So let's do this question now. So this was the situation, and if you remember, E was given to be half, right? So what is the velocity of com, dear students? So this will be 6 into 4, 24 plus 1 into 1, that means 25 by 5. So you can see that velocity of com comes out to be 5 meter per second, right? Velocity of com comes out to be 5 meter per second. So let's see the situation in the com frame. Now in the com frame, com will not move. You remember that nothing moves in this in its own frame. So in the com frame, com will not move. So if you look at if you look at block A, so block A will be moving at 1 meter per second, right? This will be moving at 1 meter per second in the com frame, right? Block A, because the com was moving at 5 meter per second and the block A will be moving at 1 meter per second, right? And similarly, the block B, if you see, block B will be moving at 4 meter per second in the leftward direction, because com was moving at 5 meter per second and the block B was moving at 1 meter per second. So com will feel as if block is moving towards left at the speed of 4 meter per second, right? So you can see that these are the velocities in the com frame. These are the velocities in the com frame. What is the next step? Multiply by half and reverse the direction. So that means block A will return at a speed of half into 1 in the com frame, and block B will return at a speed of 2, because half into 4 is 2, half into 4 is 2, okay, in the com frame. So these are the velocities after the collision. Remember, these are the velocities after the collision in the com frame. And remember, the com was moving at 5. So what will the velocity of A in the ground frame after the collision? Plus 5 minus half, that means 4.5. And what is the velocity of B? Plus 5 plus 2, that means 7. If you can see, we had exactly found out the same answer, 4.5 and 7. So I have not written any equation, just done simple plus minus thing, and we have found out the answer. I hope guys you would have understood. Just write quick yes on the chat if you have understood this. If you have understood this, just write quick yes. How many of you have understood this? What I will give you the explanation. I will just give you the explanation that why is this working, but it's very amazing method. Okay, what have we done? We have found out the velocity of com. We have written the velocity in the com frame. Then we have multiplied by e and reversed the direction of the velocities after the to find the velocity after the collision. And then we have again found out the velocity in the ground frame. This is what we have done, right? Now let's do one more example, and then I will give you the rationale. Then I will give you the reason why can we do this. So if you think carefully, so in this question also, what is the velocity of com? So velocity of com is nothing but 6 into 6, 36. minus 4 into 4 16, because this is going left, so you will have to take minus, divide by 10. So this becomes 20 by 10, that means 2 meter per second. Hence com is moving at 2 meter per second towards the right. So in the com frame, this 6 kg will move at 4 meter per second, and this 4 kg will move at how much? 6 meter per second. So after this is before the collision. Here E I have taken 1. So you just have to reverse the velocity. So this will move at 4 with respect to com, and this will move at 6 with respect to com. So now what will be the velocity after the collision? This is in the com frame. So com was moving at plus 2. So velocity of 6 will be plus 2 minus 4. That means minus 2. That means leftwards. Okay. And velocity of 4 will be 6 plus 2 8. So that means this will be the answer. So basically you can see how fast this is, and superb technique is going to give you the answer. I hope you have understood how we are doing this velocities. Not how, at least what we are doing. How I'm going to explain now that why can we do this, or what you will do to why is this method working. So this works for any value of e. It's not that e has to take any particular value. E can be 1, e can be 0, e can be half, e can be 1 by 3 by 4, any value, right? So you can see why is this method. Now let's go into the reason why is this method working. Okay, see, the basic concept is that the center of mass frame in the center of mass frame, the linear momentum of any system is always zero. Okay, in the center of mass frame, this linear momentum of any system is always zero. This is a very, very powerful rule. What I'm saying, in the center of mass frame, the linear momentum of any system is always zero. How can I prove this? I can prove this in one line. See, if you want to write the momentum of any system, if you want to write the momentum of any system, okay, so how do you write the momentum of any system? So simply one way is to in the ground frame. If you want to write the momentum of any system in the ground frame, so how will you write? One method is mvcom. Just take the mass of whole system and multiply by velocity of center of mass. So this gives you the velocity of this gives you the momentum of the system in the ground frame. Okay, momentum of the system in the ground frame is mvcom. So if you want to find the momentum of the system in the com frame, what will you do? You will write m into vcom with respect to com. Okay, vcom with respect to com. And you know that velocity of com with respect to com will be 0. So we can say that for any system, the momentum in the com frame always comes out to be 0, right? So basically, the system has a linear momentum 0 in the com frame. I hope you would have understood this. Okay. Now, how can we put to good use this result? How can we use this result for our benefit? Remember, even if you just look into the questions that I just did, if you see A was at 4 kg and B was 1 kg, if you see A was 4 kg and B was 1 kg, right? So before collision, what was the momentum of A? It was 4 into 1. In the com frame I'm talking about, not in the ground frame. In the com frame, the momentum of A was 4 into 1 and momentum of 1 was 1 into 4, and both were equal and opposite. You can see that it was plus 4, it was minus 4. So momentum was 0. Even after the collision, if you see. So the momentum of A was 4 into half, that means 2 towards this direction, and this was again 1 into 2, that means 2 towards this direction. So again it is coming out to be 0. If you see, the momentums are cancelling in the com frame. It will always happen. For this question also, if you check, the momentum of 6 kg was in the com frame was 6 4 24, okay, towards right, and for this it was 6 4 24 towards left. So again they cancelled. If you think here, again it was 6 4 24 towards left, and it was 6 4 24 towards right. So it will cancel. So momentums are cancelling out in the com frame. It will always happen. Linear momentum will have to be 0 in the com frame, right? Now let us try to find why this method works. So let us say in the com frame, let us say in the com frame, let's say this is mass m1 and this is coming at u1, Remember, I'm talking about com frame. So this is coming at u1 in the com frame. Okay, u1 in the com frame, right? Let us say this is coming at u2 in the com frame. So u2 is the velocity of m2 in the com frame and u1 is the velocity of m1 in the com frame. Since the linear momentum must cancel out, so m1 u1 that should be is equals to m2 u2, right? Let us say they go back. Let's say m1 goes back. M1 goes back at v1. Let's say m1 goes back at v1 and m2 goes back at v2. Okay. Since the linear momentum must still cancel out because this is in the com frame. v1 is the velocity of the block in the com frame. v2 is the velocity of the block in the com frame. So again, we will have m1 v1 is equals to m2 v2. This situation must still hold because the linear momentum must still be zero. Okay. So now what you can understand from here that one thing we have understood that u1 by u2 will be is equals to v1 by v2. That means final velocities ka ratio. That means v1 by v2 will be equals to initial velocities ka ratio. u1 by u2 will be equals to v1 by v2. Initial velocities ka ratio will be equals to final velocities ka ratio. This thing will remain intact. First thing. Okay. Second point is what you should understand over here is that velocity of separation upon velocity of approach. This is what E says. So what is the velocity of separation after the collision? So that is v1 plus v2. And what was the velocity of approach before the collision? That was u1 plus u2. That means we have got v1 plus v2 is equals to E times u1 plus u2. Again, a very beautiful observation. So that means if you see the sum of final velocities, or let me say speeds, the sum of final speeds has become E times the sum of initial speeds. The sum of final speeds has become E times the sum of initial speeds, whereas the ratio remains the same. The ratio of v1 and v2 has remained equal to ratio of u1 and u2. So this can only happen if v1 is E times u1 and v2 is E times u2. See, in only this case, v1 by v2 will become like if you see, if you only this is the possibility. This by this will become this by this, so E will cancel out. So this ratio will be maintained, and what? And you can see that v1 plus v2 is coming out to be equals to E times u1 plus u2. If you can solve, you can treat these two as linear equations and you can solve for v1 v2. You will find this value v1 equals to eu1 and v2 equals to eu2. You will get the value like this. So basically v1 has to become E times u1 and v2 has to become E times u2. Then only the summation of v1 plus v2 will become E times u1 plus u2, and also the ratio of v1 and v2 will be same as ratio of v1 and u2. So which is what I had asked you to do. Basically multiply u1 by E to get v1 and multiply u2 by E to get v2. That is the rationale behind doing all what we did. I hope guys you would have understood. I hope you would have appreciated this amazing technique, because now you will not have to write the whole big equations of momentum conservation and coefficient of restitution. Rather you can simply, very simply, you can uh, use this com frame to your benefit and you will be able to solve the question, right? I hope you would have understood. So let's move to the concept 4. The tension developed in a circular wire which is under uniformly distributed radial force is the total sum of magnitude of radial force divided by 2 pi. It's a very useful concept for JEE Advanced questions, and I'm sure that if you have prepared for JEE Advanced, you would have definitely done the question. You might not realize what I'm talking about right now, but I would have definitely done this question, done similar questions. So let us see what I'm talking about. I have taken several questions. If you see what we are saying, suppose there is a ring. Suppose there is a ring. The ring has Q2 charge which is uniformly distributed throughout the ring. So let's say the charge Q2 is distributed uniformly throughout the ring. Okay, and Q1 charge is kept at the center. So you can feel that there will be some tension which will develop in the element of the ring, in the body of the ring. The reason is that because of electrostatic repulsion, because of electrostatic repulsion, the ring will try to extend, the ring will try to expand. But since it is a rigid body, or we can say since it is not allowed to expand freely, so there will be some tension, right? So how to write the value of that tension? So that is what we have written over here. The tension developed in a circular wire which is under uniformly distributed radial force is equals to the total sum of magnitude of radial force divided by 2 pi. So what does this mean? If you think this dq charge, which is over here, dq charge, dq. So what will be the force on this dq because of capital Q1? That will be k q1 dq by, I'll write this df. That will be k q1 dq, okay, divide by r square. R is the radius of the ring. The same force will be experienced by this dq. The same force will be experienced by this dq. The same force will be experienced by this dq. The same force will be experienced by this dq. So you can see this total rate and the forces will be in the radial outward direction. So you can see that this will have experience force radially outwards. This will also experience the force radially outwards. This will also experience the force radially outwards. So you can see that this force, uh, the force developed, the force developed due to the, and we have to find the tension developed just because of Q1. We have to ignore the force. See, there will also be some force that the remaining ring will be applying on this dq. So I'm ignoring that because that will make the question complicated. So I'm ignoring the force that the remaining ring will apply on dq. So we are ignoring that right now. So basically you can see that the force is uniformly distributed. This total force, if you add the force on the ring, so that will be k q1 by r square into dq, k q1 by r square into dq, dq will add up. So total force will become k q1 into q2 by r square. If you add up the magnitude of each force, vector sum will come out to be 0, because if you see then on this dq, in the top dq and the bottom dq, top dq and the bottom dq will cancel out each other. So vector sum will come out to be 0, but if you add up the magnitudes, then it will become k q1 q2 by r square. And this force has been distributed uniformly on the ring. You can see this force has distributed uniformly on the ring. So if you go back to the statement, the tension developed in the circular wire is the total uniform force divided by 2 pi. So what will be the tension? This is the total sum of the magnitudes of the force which was acting on the each element, right? If you add up the force acting on the each element magnitude wise, so the value will be k given due to by r square, and this divided by 2 pi. So this will be the value of the tension. This will be the value of the tension that will come in this ring. I will also prove this very, very shortly, but I hope you would have understood this result. Very important result, guys. So let's again see this question. This question has been solved in HC Verma book as well. It's a solved example. If you, so what is happening over here? Suppose this is a ring which is in a gravity-free space, and let us say this ring is rotating at an angular velocity of omega. This ring has a mass m and radius r. So because of the rotation about its own axis, there will be some tension developed in this ring. The reason is because you can think in terms of centrifugal force if you want. Every element will try to escape. Every element, if you talk about this element, it will try to escape. Okay, this element will also try to escape. So every element is trying to escape, but it is not allowed to escape because it is held by the neighboring elements. So basically, if I, what will be the tension developed in this? What will be tension developed in this? So again, you can add up the centrifugal force acting on each element. So if you take this element as dm, so what is the centrifugal force acting on this element? That will be dm omega square r. That will be dm omega square r. So for this element also dm omega square r. For this element also dm omega square r. So centrifugal force acting on each element will be dm omega square r in the radially outward direction. So if you add the magnitudes of each, if you add the magnitudes of each, okay. So this is not the tension. This is the centrifugal force which I am talking about. So if you add df, 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 df magnitude wise, not vectorially, then total F will become m omega square r. This is the total force which is acting on this ring. In fact, if this is the total sum of the magnitudes of the force of which is acting on the each element, and the tension developed, since you can see that this force is distributed uniformly, that means on whatever the force is this element is experiencing, the same force is this element experiencing, the same force is this element experiencing, and the same force is this element experiencing. So we can say that tension developed will be F upon 2 pi. That will be m omega square r upon 2 pi. So this will be the value of the tension developed in this ring. I hope guys you would have understood. I have taken one or two more questions. So here what is happening? There's a cone. There's a cone. It's a good question. If you do not know this result, then you might take some time to solve this. But if you know this result, then you can solve this very fast. So this is a cone. Okay, and the apex angle of cone is 90 degrees. So that means this half of apex angle will be 45. Now you have placed a circular loop. You can imagine a circular rope, and you have just placed it. So it settles at distance h. That means right now it is not going to go down further because now it is properly in contact with the cone. Okay, so this height has been given to be h. So you have to find it tension in the ring. Okay, tension in this rope. The mass of the rope is m. If you think like what is happening on this rope, why, like what are the forces acting on this? So basically a normal reaction will be going, we can say, at an angle of 45 degree with the horizontal, or at an angle of 45 degree with the vertical. Okay, so I'm showing this n as at an angle of 45 degree. Okay, now you might feel that there will be two normal reactions, one from this side but one from this side. It's not like that. If you think in three dimensions, it's 3D, so it's single loop. So I have just, so normal will be distributed on this whole ring. Normal will be distributed on this whole ring, whole rope. I have just shown that to be acting at one point, but yes, will be distributed on this whole each and every part of the ring, right? So I'm just showing you just like this, and mg will of course be acting in the downward direction. Okay, now these are the external forces. These are the external forces. So basically, we can say that the upward component of normal is balancing mg. N cos 45, n cos 45 is balancing mg, right? What is happening to n sin 45? Now, if you think carefully, as I told you, normal is distributed uniformly. So the normal which is acting at this point, the horizontal component of this will cancel out the horizontal component of this. So if you take the vector addition, then normal will cancel out on this whole ring. That means this dn and this dn will cancel out. This dn and this dn will cancel out. Diametrically opposite dns will cancel each other. Okay. So what is happening, if you think carefully, the horizontal component of normal reaction is trying to expand the ring. It is trying to elongate the ring. If you think, vertical component of normal reaction was just trying to balance mg, but the horizontal component of normal reaction is trying to expand the ring. Okay, just like what was happening in that electrostatic question. So because of which tension is going to develop, because of which tension is going to develop. So what will be the value of the total force? What will be the summation of the magnitudes, not the vector addition now, summation of the magnitudes? So it will be dn dn sine 45, dn sine 45, dn sine 45. So if you just add all this dn sine 45 magnitude wise, so what will be the total force? So that will be n sine 45. Okay, and that divided by 2 pi. So this will be the value of the tension developed. I hope you would have understood. So n sine 45 and n cos 45 will be same. They will be equal in magnitude. So this will become mg upon 2 pi. Okay, I hope guys you would have understood this. It's a very, very nice method or nice result to remember. So same question you can see here. This is a question of surface tension. I would ask you to try this on your own. I will just quickly explain what is happening over here. So this is a rectangular loop. This is a rectangular loop. Okay. And right now this was a soap film. So here we have soap film which is formed inside this loop. So right now this is a thread this is a thread which is of length L. So total length of the thread is L, and it is in the shape of loop. Okay, random loop. Now, if you prick this soap film inside the thread, that means this region, if you prick the soap film, that means there will be no soap film left within this loop. So generally, you would know that what will happen to the shape of the loop. Since the soap film is present outside the loop, that means in this region the soap film is present, but inside the loop the soap film is not present. So it acquires the shape of circle. Okay, because circle is the only shape at which can help it to stay in equilibrium, because the net forces will cancel out. So if you see the surface tension will act radially outwards, okay, for each element. And there are two surfaces which will be in contact. For example, how do you write on a sheet of paper? You write on one side and you then flip the page and you write on the same sheet other side. So for every sheet you have got two pages, right? So similarly, this soap film, imagine this soap film will have two free surfaces, one from our side and one from back side. Okay, so think very, very carefully in three dimensions. This soap film will have two free surfaces, one from this side, which you can see, and one from the back side. So this thread is in contact with both the free surfaces. Okay, this thread is in contact with both the free surfaces, because you can feel as if the thickness of the thread is very, very small, which will also, we can assume that it is same as the thickness of the soap film. Okay, soap film is almost is of the same thickness which is of thread. So you can see that, the thread is almost is in contact with both these free surfaces. So try this question, guys. You will get using the same result. The total answer, I will tell you, the total answer will come out to be 2SL by 2 pi. Okay, so this will be the surface tension developed. Think how I wrote this is a very, very standard result. Okay, now how can we prove this? How can we prove this? So very simply, again, I have taken the same question. Okay, I will show you two different methods to prove this. Okay, so suppose this ring was moving at an angular velocity of omega. Okay, so one method which you most of you would have done is taking this element, okay, taking this element, okay, let's call this angle as d theta. Let's call this angle as d theta. So I'm showing you this element. I'm showing you this element. So tension will be acting like this T and T. This angle is d theta. So here you can see tension will be acting like this T and T, right? This angle is d theta. So I'm drawing the y-axis. Okay, I'm drawing the y-axis. So this angle will be d theta by 2. So just write the y component of the tensions acting on this element, and that will be equals to mass into acceleration of center of mass of this element. So the y component is this. Okay. So this angle is d theta by 2. This angle is also d theta by 2. So what is this angle? 90 minus d theta by 2. 90 minus d theta by 2. So the y component of tension comes out to be t cos of 90 minus d theta by 2, and same will be this side t cos of 90 minus d theta by 2. So what is the total force, total tension acting in the downward direction? 2t into cos of 90 minus d theta by 2. This is the total force acting on the element in the y-axis. This will provide the centripetal force, or you can equate it to centrifugal force, whatever you want. If you want to go into the rotating frame, then you can equate this to centrifugal. If you want to do this in the ground frame, then you could equate it to centripetal force. So 2t into cos of 90 minus d theta by 2, that will be equals to dm omega square r. Dm omega square r, right? Dm omega square r. So this cos 90 minus d theta by 2 will become sine d theta by 2. Okay. Dm ko you can write m by 2 pi into r to m by 2 pi into d theta, or you can write m by 2 pi r into r d theta. So this is the value of dm into omega square r. Since d theta is a small angle, so you can ignore this sign, because sine of small angle is also a small angle. So if you ignore this sign written over here, so 2 and 2 will cancel out, d theta will cancel out d theta, r will cancel out r. So t comes out to be m omega square r upon 2 pi, which is exactly, if you remember, I had told you that this was the total radial force divided by 2 pi. So I hope you would have understood. We can prove this by one more method. which is easier than this. We can prove this by one more method. Okay, let us see that method as well. Consider the half ring, this part. Okay, just look at the half ring. Okay, just hold on. I'll yeah. So this was the full ring. Okay, which was rotating at omega, right? Mass was in. Consider the half ring. Okay, so that means top half. Let us say. So the bottom half will be applying tension like this on the top half. So this I have shown the tension acting on the top half, T and T. Who is applying this tension? Bottom half is applying this tension on the top half. Okay. So again, we will use F external equals to ma com on the top half of the ring. So where is the center of mass of this? So center of mass will be at a distance of 2r by pi. You know this, for a semicircular ring, the center of mass lies at a distance of 2r by pi. So F external on this top half is 2t. That will be equals to mass, which is m by 2 into acceleration of center of mass. Center of mass is moving in a circle of this. Center of mass will be moving like this. So it is moving in a circle of radius 2r by pi. So 2t is equals to m by 2 into omega square into radius. Radius is 2r by pi. So you can see what do we get? T is equals to m omega square r upon 2 pi. So basically this is the tension in the ring. I hope guys you would have understood. So for today, I am calling it off. There was one more concept that I had taken, which I had told you that we can write the work done by the Buoyancy force. I told you by much shorter method. So that concept I will cover in tomorrow's class. So I hope you would have liked today's concepts. So they were fast methods, the methods to avoid integration. I will definitely talk about more concepts in tomorrow's class, which you can use, okay, to save your time. Okay, and we will see some concepts from electrostatics. We will see some concepts from springs, which will be definitely handy to you in saving your time. So that was all, guys. Thank you so much. Bye bye.